value and the actual value. Variance is another term. If the machine learning model performs well with the training data set, but it does not perform well with the test data set, then there is a variation in the model. So overfitting occurs when our machine learning models try to cover all the data point or more than the required data point present in the given data set. So because of this overfitting problem, the model starts catching noise and inaccurate values, and all these factors reduces the efficiency and accuracy of the model. By means of this overfitting problem, the model has low bias and high variance. Overfitting mainly happened in the supervised learning algorithm. So in this diagram, the overfitting problem is clearly represented in the graphical manner. Here the values are split, represented in the scattered way. So we cannot find the best fit line from this graph. So there is no proper line to gather all the data. So overfitting problem comes in this scenario. We can avoid this overfitting problem using various technique, cross validation. We can training the same machine learning model with a more number of data set. We can removing the features, yearly stopping the training, regularization method, and ensampling method. Another problem in machine learning is underfitting problem, which occurs when our machine learning model is not able to capture the underlying trend of the data. To avoid this overfitting model, we fed the training data, and that can be stopped at earlier stage, due to which the model may not learn enough training data. As a result, it may fail to find the best fit of the dominant trend in the data set. So in this case, the underfitting problem comes into the picture, which is not able to learn enough from the training data, so that it reduces the accuracy and the prediction rate also unreliable. So this unfitted model has high bias and low variance. So this diagram tells about the underfitting problem, which increases the training time of the model and increases the number of features. So the model is trained, but even though the model is trained properly, okay, if any training input, it in some cases it cannot predict the value correctly. So to avoid a overfitting problem, we used cross validation technique, which is a resampling technique with the fundamental idea of splitting the data into two parts: training data and test data. Training data is used to train the model, and the unseen test data is used for the prediction for future. If the model performs well over the test data and gives good accuracy, then the model has not overfitted the training data and can be used for prediction as well. So there are certain steps required for the cross-validation techniques. Preserve the subset of the data set during the validation time. Provide the training to the model using the training data set, and evaluate the model performance using the validation test. If the model performs well with the validation set, perform the further steps, or else check any issue is coming. First technique is a holdout method. Here we can divide the entire benchmark data set into two sets, a train set and a test set. The data can be divided in such manner that 70% is used for a training purpose and 30% is used for test purpose, or it may be a 60-40 ratio, 75-25 ratio, or even 80-20 ratio also. So the proportion of a training data has to be larger than the test data. So this is a holdout method. We can classify them into training phase and testing phase. There are some problem in holdout method. The error rates are highly variable, and it totally depends on which observation we are using. Second method for the cross validation, leave one out cross validation method. Here we divide the data into train and test, but with a twist. Instead of dividing the whole data into two subsets, we select a single observation as a test data, and everything else is labeled as a training data. The model is trained using the uh, using the unlabeled information. Now, in the second iteration, The second observation value is selected as a test data, and the model is trained again based on the remaining data. So in this diagram, the x is having the value 10, 20 up to 100. So in the first iteration, the index value 0 is taken as a single observation. That is, remaining values are trained. So this single observation is used for testing purpose. In second iteration, the second index value is taken as a observation. Remaining values are trained. So repeat the process until all the single observations are revisited. So in k-fold cross-validation, this is a resampling technique. The whole data is divided into k sets of almost equal size. In first set, the selected test data is trained for the remaining k minus 1 test. If the test error rate is coming, then the model is calculated after fitting the model. In second iteration, the second set is selected as a test set, and the remaining k-1 sets are used for training the data, and the error value also calculated. This process is repeated for all the k set of data. So in iteration 1, the test data, k block of data is considered as a test data, remaining data is used for training purpose. In iteration 2, next k bits of blocks are taken as a observation data, which are used for testing purpose. Remaining data are used for training purpose. So this process is repeated until all the k values are uh, uh, verified. Then last method, stratified k-fold cross validation. In this, we use a stratified sampling instead of a random sampling. Now, if your data contains cosmetic product of two views, one is based on the female classification and another one is based on the male classification. In such manner, if we divide the training and testing in random method means, in some cases, most of the data representing males is not represented in the training data, but might end up with the test data. So when we train the model on the sample training data, this is not correct representation of your actual population. So the model will not predict the test data with a good accuracy. So that the stratified sampling method comes into the picture. Here the data is splitted in such a way that it represents all the classes into a single population. So this remaining data are trained using this k-fold stratified inputs. So each round, there are two classes of training data and testing data. One is representing the female classification, another one is representing male classification. In the second iteration, the second block of male and female classifications are observed along with the remaining set of a training data set. So this process is repeated for all the block of data are revisited. These are the some of the references available. That's all about machine learning basics and cross validation techniques.